All right, guys, 10.1, starting chapter 10 here. We are talking about square root functions, and we're really only dealing with two sections out of chapter 10, and we normally do a lot more than that, but we're really cutting this one down. It's not necessarily something that is super important for geometry, but it is something that we should know heading into Algebra 2, which is why we're still covering it here. So we are dealing with square root functions. And square root functions, function that contains the square root. Okay, so your variable, your x variable, is under the square root. And you see this is the parent function of our square root functions, right? We've talked about parent functions before, the most basic that you can have. If you look at it, it's f of x is equal to the square root of x, right? Here is our parent function. And if you were to plug in a 1 in there, the square root of 1 is 1. So there's our point, 1, 1. If you were to plug in a 4, and the reason why I plug in a 4 and not a 2 is because 2 is not a perfect square. So taking the square root of 2, I'm going to get 1.41 or something like that, and I don't want to graph that. So when I plug in numbers, I'm going to plug in numbers that are going to give me a perfect square under that square root. So if I plug in a 4, square root of 4 is 2. Right? That's that point right there. Square root of 9, the next perfect square, square root of 9 is 3. So you see it there. And that is the form that it's going to take. It's going to look like that. If you right now turn your head to the right, turn your head 90 degrees to the right, you will see that that is half of a parabola. Right? So it's half of a parabola on its side. That's what a square root function is. Now, we don't have the bottom half of that because then it wouldn't be a function. Remember, then it would fail the vertical line test. So we just have the top half of that. We're not worrying about any negative answers for this. All right, so that's our square root function. Now it says the value of the radicand in a square root function cannot be negative. Right? So the domain of a square root function includes x values for which the radicand is greater than or equal to 0. So it can't be negative, right? We can't take the square root of a negative. You can't take the square root of a negative 2. So a big part of this is going to be finding the domain. Okay, finding the domain of the square root function. So the domain, we know that under the square root has to be greater than or equal to 0. It can't be negative, which means what we can do is we can take what's under the square root sign, so that x minus 5, and we can say, all right, x minus 5 has to be greater than or equal to 0. Because whatever I plug in, right, whatever I plug in, that radicand, the radicand is the square root sign, the radicand has to be 0 or it has to be positive. It can't be negative. So x minus 5 is greater than or equal to 0. So I would add the 5 over, of course. I solve it out. X is greater than or equal to 5. That would be my domain. That would mean when I go to graph it, I can only graph points that are greater than or equal to 5. I can't graph a 0. All right? I can't graph a 4 because those would give me negative numbers in the square root. Can't do that. Okay, so that's finding the domain of the function. And you're going to be asked to do that quite a bit. Simply take, just like I did here, take what's under the square root sign and make it greater than or equal to 0. Notice I didn't do anything with that 3 that's out front. All I worried about was under the square root sign. So what's under the square root sign, make that greater than or equal to 0, and we can move from there. Now, if we look at this next example, and it talks about graphing, and we're not necessarily going to graph on the assignment, but I do want to point it out just to show you what we would do in terms of graphing. The first thing we would do is you got to think about the domain, right? And the domain is what is going to make what's under the square root sign greater than or equal to 0. Well, it's just x under the square root sign. That plus 3 is not part of the square root sign, right? That's separate. So what's under the square root sign is x, which means our domain is simply x is greater than or equal to 0. So I can graph any point that's greater than or equal to 0 there. When we go to plug in numbers, and we would do a whole lot more with this if we were in class, but when we go to plug in numbers, we want to plug in numbers that make what's under the square root sign perfect squares. We want what's under the square root sign to always equal 0, 1, 4, 9, 16, because that means I can take the square root of it, right? So in this case, since it's just an x under there, I would plug in exactly those numbers. I would plug in 0, 1, 4, 9, and 16. So I would take the square root of that and then add 3 to that answer to get the points. And you see on our graph that those are the points that we have, right? Our graph's over here on the left. So that's how we would do it. We would plug in numbers so that we can take the square root easily and then get those. What we're going to do instead now, especially with this at-home learning, instead of graphing, we know how big ideas is. You're not going to have to graph that function. You're going to have to choose which graph is correct. And to choose which graph is correct, we don't actually have to come up with those points. What we have to do is we got to pay attention to the transformations. So that's what we're going to concentrate on is the transformations. Remember, anything that happens outside of the parentheses or outside of the absolute value, or in this case, outside of the square root sign. Anything that's happening outside the square root sign is a vertical change. So it's outside the square root, so it's a vertical change. This is going to be a vertical translation up 3, which means we're going to take where that, remember we had that parent function, which was here, 4, 2, let's see, 9, 3, it looks sort of like this. We're going to take that whole thing, we're going to shift it up 3, right? So really what we want to concentrate on is this point right here, that starting point. That starting point should be at 0, 0 for the parent function. Here we are moving up 3, so that new starting point is just going to be 3 higher. Okay, and that's going to help us determine which of these graphs is correct. Okay, that's what we're looking at. So let's move down onto the next page here. Radical function is a square root function. That's what we're dealing with, our radical functions, right? But let's look at these transformations, okay? These transformations. Again, anything that happens inside of the square root sign. Anything that happens inside the square root sign is going to be horizontal. Okay, so let's write a note here. Inside is horizontal. Outside of the square root sign is going to be vertical. It's going to be a vertical change. So when we look at this, horizontal translation, okay, it happens inside of the square root sign. And just like everything, when it happens inside, it's the opposite of what we see. So we have x minus 2 here. That's 2 to the right. Okay, we have a plus 3. That's 3 to the left. Remember, that's the opposite of what we see. So if we're simply adding something to our x and it's inside the square root sign, that is that horizontal translation left or right. Now, when it happens outside, we already sort of talked about it. When it happens outside, that's a vertical translation. Now we're going up or down, and it's exactly what it looks like. We have a plus 7 that's outside of the square root. We're going up 7, right? If we have a minus 1 outside the square root sign, we're going 1 down, okay? Other ones that we got to look at, reflection, okay? If it happens inside the square root sign, that is a horizontal reflection, which means we're reflecting side to side. It's over the y-axis here, over the y-axis. So this one would be, if I'm here, that's the parent function, and then I see this negative on the inside, that negative on the inside is going to make it look like that. Okay, it's going to be a horizontal reflection over the y-axis. Now this bottom one, if it's outside, it's going to be reflecting it over the x-axis. So instead of, let's see if I can, instead of reflecting over the y-axis, I'm going to reflect over the x, and now it's going to be down here. It's going to be that bottom part of that parabola. Now if I have that negative outside the square root, right? So know your reflections. The other one that we have, horizontal stretch and shrink. You're not going to see too much of this. You might see it a couple times here. But again, if it's on the inside, it's multiplied, then it's the opposite. It's the sorry about that. We're looking at the reciprocal of that number. That's the factor. Okay, so we're looking at the reciprocal. So it's multiplied by 3. We take the reciprocal. That's a factor of 1/3, which means it's getting smaller. Okay, if we're multiplying by 1/2 on the inside of the square root, and they messed up here a little bit. Let me just point that out. That should be covering the x. If we're multiplying by 1/2, we take the reciprocal, which is 2, which means we are stretching it by a factor of 2. Okay, so that's the horizontal stretch or shrink. We're going away or closer to the y-axis there. A vertical stretch or shrink, we're multiplying by something on the outside. We've done these before. It's exactly what it looks like. You're multiplying by 4 on the outside. It's a stretch by a factor of 4. Everything's getting taller or further away from the x-axis by a factor of 4. Multiplied by the 1/5, it's shrinking down. This is important, okay? This is how you are going to determine which graphs are correct here. And the only other way to do that would be to plug in numbers and check. So if you get stuck, you can still plug in numbers, right? Plug in a 1, a 4, a 9, see what happens, see what points you get. But if you know your transformations, it's going to be a whole lot easier for you. All right. So that's what example 3 talks about here, right? We see our two transformations. We have the negative on the outside. The negative on the outside tells me it's going to be a vertical reflection or a reflection over the x-axis. And then that -2 on the inside tells me that I'm going to move to the right 2. So that starting point, again, we always start with that end point. I know that I'm going to go to the right 2, we said, and then everything is reflected over the x-axis. So instead of being up here, it's going to be down here. So that would be the graph that we're looking at. So really that's what we need to know for 10.1. It's going to go on and talk about how to graph all of this stuff. This is just using those transformations still, right? This is 3 to the right and 2 down, a stretch by 2, a vertical reflection over the x-axis. There's a lot of stuff. We would have gone into this if we were in school. You're not going to see anything about that. You're not going to see anything about example 5 or example 6. Okay, a lot of extra stuff there. Really what we're looking at is examples 1, 2, and 3. Can you find the domain, right? Take what's under the square root sign, make it greater than or equal to 0, and solve. That's the domain. And can you choose the right graph, and can you talk about what transformations are happening? That's what we're looking at for section 10.1, and that should be all that you need to know.